The objective in this lesson is to be able to use a limited amount of information about side lengths and angle measures to prove triangles are congruent. Recall the 5 congruence postulates and theorems: side, 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 angle, 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 side, and hypotenuse leg. Also remember that there is no roadside service. That means AAA cannot be used, angle, and no cursing in geometry. Well, remember the SSA? If you read it backwards, then you know what I'm saying. So here are some things to look out for that can happen when you're talking about more than one triangle. A lot of times triangles aren't drawn separately, but they're drawn connected, like in these pictures. One thing you'll come up to see sometimes is that two triangles share a side. That is the reflexive property. Remember that sides are congruent to themselves. Like in this picture, you have the triangle that's on top, this triangle right here, and then you have the triangle that's underneath, this triangle right here. And notice when I trace the triangles, I trace over the same side. So this segment right here is congruent to itself. So we'll put a congruent mark on it. Now we can see these two triangles separately if we want to. If I separate them, they look like this and like this. And I'll put those same congruent marks. Now we don't have to do that, but the point is this side is congruent to itself. Now, if this side had endpoints that had names, such as A and B, we would write that AB is congruent to itself, AB. Remember the reflexive property. It's like looking in a mirror. You see a reflection, and a reflection of yourself shows you the same exact person. This triangle as well shows two different triangles. We've got the triangle on the left and the triangle on the right. And notice when I trace over the two triangles, I trace over this side for both of the triangles. Therefore, that side is congruent to itself. Now, unlike this one where I already had used the 1/ and the 2/, so I had to use the 3/, here none of the sides are marked congruent yet. So I'm just using a 1/. Let's see these two triangles drawn separately. You have the triangle on the left that I traced in blue, where the angle up top it has a congruent mark, and the angle to the right has a congruent mark, and then of course the shared side that has the congruent mark. Then we have the triangle to the right, where the angle at the top has the 1/ congruent mark, and the angle to the left has the double/ congruent mark, and then of course the shared side has the 1/ congruent mark. Now, similarly to what I showed in this first picture, if these 2 points were named like C and D, we would say that CD is congruent to itself. Now remember that even if I write CD is congruent to DC, that's still the reflexive property. So it could look like this, or it could look like this. Let's answer the question, which theorem or postulate makes these triangles congruent? So looking at the first picture, and maybe I look at how they are separated, I'm going to write that I have a side mark, here I have a side mark, and here I have a side mark. So without even having to put my X's, that's pretty easy to see that that's side, side, side for that picture. How about over here? Well, it's hard to do it when they're connected, so I'm going to look at them separately. I have an angle mark here, an angle mark here, and a side mark here. Now we have to choose between angle, side, angle, and angle, angle, side. So let's put X's on the parts of the triangle that are not marked. Like this angle does not have a mark, this side does not have a mark, this side does not have a congruent mark either. Remember that we don't want to go of the path where we go over more than one x. So if I start at this A, I can't go this way. So I'll go start at the A here, go over just one x towards this A, and then stop here. So angle, angle, side. That's what makes these triangles, oops, I said angle, angle, side is what makes these two triangles congruent. Another thing we'll come across is vertical angles. Remember that vertical angles are congruent. They're not going to mark vertical angles for us in the picture. We just have to remember to see them. Remember our bow tie angles, or the angles right across from each other from the intersecting lines? Those are congruent to each other, so I'm going to mark them in the picture. Now I had to use the double slash because I already had a single slash. Now if I were going to name what I just marked here, I would need some points. So I'm going to label the points that are here. Let's see. We'll go A, B, C, D, E. So I'm going to say angle A, B, E. That names this angle to the left is congruent to. Now when I name this angle over here, again I want the B to be in the middle because the B is the vertex, but I want to go in a similar direction that follows the similar markings. So because I ended at E, which has that congruent mark, C corresponds to it, I'm going to end in C. That leaves me with D to be the first letter. So this is how I'd show that the vertical angles with vertex B are congruent to each other. Now let's answer the question, which theorem or postulate makes these triangles congruent? So if I focus on just one triangle and I say, I see this angle's marked, I see this angle's marked, and I see this side is marked, then I can say, okay, it's either angle, side, angle, or angle, angle, side. Probably the x's will help here too. So this one is not marked, this side is not marked, and this side is not marked. So I do not want to go over two x's. So if I start here, then I would go that way, which would mean S, A, A. But that's not the order that we do it, so we'll go this order, A, S. We go alphabetically. Angle, angle, side. Let's write it over here to answer the question. Angle, angle, side. A third thing you might come across is parallel lines. These often will be marked or given to you. Remember that alternate interior angles and corresponding angles come from parallel lines and that they are congruent. So in this picture right here, we see the arrows. Remember the parallel lines are marked by arrows on the lines that are parallel. Well, these lines are the parallel ones, so we have alternate interior angles here. Remember when I showed you that you can make the z to find those alternate interior angles? So here's a parallel line, here's the transversal, and here's another parallel line. So where are the first pair of alternate interior angles? Here and here. These angles are congruent. Let's go ahead and label these vertices. We'll label this one here A, B, C, D, and E. So angle B is congruent to angle D because of the alternate interior angles. But I could have drawn the Z the other way. This way, from here down to here, the transversal, and then down this way. So now where are the alternate interior angles? This one and this one. Angle A is congruent to angle E. Now let's look at these two triangles and figure out which theorem or postulate makes these triangles congruent. If I focus on one of the triangles, notice there is an angle mark here. You know what? Let's try this. I'm going to draw this triangle separate from the picture so that I don't have to have the letters in the picture confusing me. There's a double slash up here in the top, a single slash, and then a side slash. So I have an angle mark, and an angle mark, and a side mark. I don't have this side marked, so that's an X. This side, X, no angle mark, X, And now I know I don't go over two x's, so I'm going to go this way. Angle, angle, side. Let's look at the other picture where I've got arrows showing that I have parallel lines again. So where are the congruent angles now? Well, I can't draw a Z, but I'm going to highlight over these pair of parallel lines. Where would the transversal be? Right here. This is the line that's crossing, intersecting both of those parallel lines. Do you see what kind of angles that we have here? This angle is congruent to this angle. These are the corresponding angles. Let's label the vertices in this picture A, B, C, D, and E. So here, angle A is congruent to, now I can't just say angle C, because does that mean this angle C, this angle C, this angle C? There's a lot of angles with the vertex C. So because it's not distinct, like this one, I'm going to use the three-letter name DCE. That's one pair of corresponding angles in the picture. But notice we have another pair of parallel lines. So I'm going to highlight this line, and notice the transversal. So do you see the other pair of corresponding angles? Here and here. So angle, again, C, it's unclear, so we'll say BCA is congruent to, now E, there's no other angle E, so I can just say angle E. These are the corresponding angles. So this is our picture of the corresponding angles, and this is our picture for the alternate interior angles, or our examples. Now let's see if we can decide which theorem or postulate makes these triangles congruent. So I have one triangle. If I draw it separately, there's an angle mark down here, a side mark, and a double angle mark over here. So I've got angle, side, angle. That one's pretty easy to see because there are no x's in between. All the x's are up here where nothing else is marked. So this one is angle, side, angle. Now you may be given a scenario where all of the above can happen together in one problem, or at least more than one. Be on the lookout for pictures with very little marked. What do we see marked here? That's right, just the parallel arrows. Let's trace over those parallel lines and see if we can find some congruent angles. So I have a parallel line here and a parallel line here. These two lines are parallel. Where's the transversal? Here. Notice the Z shape? That gives me my congruent angles here and here. So we've got these alternate interior angles marked. And we always remember that alternate interior angles are congruent. Well, what about the other pair of parallel lines? Do you see those? Here and here, because of these arrows. Where's the transversal? That's right, it's here. So now it's this angle is congruent to this angle. These are also alternate interior angles. What else do we have here that we can mark? This side is used by both triangles, so I can mark that side congruent to itself by the reflexive property. And it's important that we know why we're marking things and that we write down what it is that's allowing us to say that they are congruent. So the reflexive property tells us that this side is congruent to itself. Now that we have everything marked that we can, which theorem or postulate makes these triangles congruent? It might be easier if we draw the picture separately. So I'm going to take this one triangle, draw it out here to the side. We've got the top side and the left side and the right side. There's an angle mark at the bottom, an angle mark at the top, and this side is marked congruent in the other triangle. Now I could mark that and draw the other triangle as well. Or I can mark these angle, side, and angle marks, and the X is where nothing's marked, and help me figure out which theorem or postulate. Well, here it is, angle, side, angle. That one wasn't too difficult.